Today we're going to take in the IUPAC nomenclature of organic compounds, right? We're going to be naming organic compounds based on the IUPAC system of naming them. Now, I'm going to be taking this with a set of questions and explaining the rules alongside while I'm solving them. So let's start with question 1. What is the IUPAC name of? We have the structure. Now, we are asked for the IUPAC nomenclature of this compound. Now, the first thing we're going to do is to identify the longest chain. After identifying the longest chain, we're going to look for which numbering system, that is either forward or backward, gives us the total lowest number possible. Then after that, we're going to use that numbering system to number the substituents. All right, so first off, let's go solution. Now, I don't really have to redraw this compound, but let's do it for clarity. All right, so we have 3 carbon chains, right, and we have this attached, right? We have the terminal carbon attached to 2 other hydrogen, right? And there's just drawing the same thing we have in the question to enlarging it. Okay. That's 1 hydrogen here, 1 hydrogen here, carbon here. We have hydrogen attached and hydrogen attached. Alright, so now these are compounds we asked to find the IUPAC nomenclature. Now, first, we said we identify the longest chain. The longest chain here can be in different ways, but if you count straight ahead, that's from the first carbon to the last carbon, you're going to have 1, 2, 3. Now, this is 1, this is carbon 2, and this is carbon 3. Remember I said that we are going to use 2 numbering systems, either the forward or the backward. If I count backwards, we are going to have here to be 1, here to be 2, and here to be 3. Now, our substituents are placed on carbon 2, and whether we count forward or backward, we end up as 2 in this carbon which is attached to our substituent. So 2 always end up with carbon attached to our substituent. They are the same number, so meaning that it's 2, that's the number we're going to attach to our substituent. All right, so now what's the longest chain here? 1, 2, 3, right? That's the longest chain. That's the longest continuous carbon chain, and we know that 3 carbons stands for propane. 3 carbons stands for propane, right? So that's the suffix we use for 3 carbons. Now, the prefix rather we use for 3 carbons. Now, these are the substituents. Let me circle. We have this substituent at one of them attached to carbon 2 and another attached to carbon 2 as well. All right, so we're going to take the numbers that these substituents carry, which are 2, right? We have 2 substituents there, so 2 comma, you separate numbers with a comma, so we have 2 comma 2. Now, since we have 2 substituents attached and both of them are of the methyl group, right? They have the methyl group. Then right here that the methyl group, which is represented as CH3, right? The methyl group is represented as CH3. We also have the ethyl group, right? That one is less common but is also important. The ethyl group is represented as C2, that total number of carbons is 2, and 5 total number of hydrogen, right? So we have 2 substituents attached, we separate them with a comma. Then since we have 2 methyl, it becomes dimethyl, right? Di is a Latin word for 2, so if it was 3, it becomes trimethyl. So we have dimethyl, we separate a dash again, right? Now remember we said that this is a 3 carbon, the longest chain is 3 carbon, right? So 2,2-dimethyl, and that become propane, right? 2,2-dimethyl propane. So this is the IUPAC nomenclature, right? So if we're dealing with other kinds of nomenclature like the common system where we give it the trivial names and the common name, right? We can also call this new pentane, but that's one other system. That's one other system of naming. Let's go to question 2. What is the IUPAC name of CH3 single bond CH, in bracket we have OH, CH2 and CH3. Now this question is quite different from here in the sense that the substituents, they are not carbon based, right? This is a functional group referred to as the alkanol functional group. Let's go solution. Right, so how do we deal with the alkanol functional group? First off, let's expand this structure, right? Expand this so it's more simpler for us to name. First, we're going to write out the first carbon there. It has 3 hydrogen attached to it. Then we have it attached to next carbon that has 1 hydrogen above and the other beneath. You have another carbon, right? That's 2. Right, so now this is much easier. Why? Now we can identify the longest continuous carbon chain. If you do that, we're going to have 1. So let's see, 1, 2, that's the 4 numbering system, 3 and 4, right? So we have 4 carbon chain as the longest continuous system of carbons, right? So if you count backwards, you're going to have 1, 2, 3, 4. Now the only substituent we have here is the OH, which is a functional group, right? And that OH, as I said, it refers to as the alkanol functional group. In this case of this compound, it's a substituent. First was the alkanol functional group. Now the alkanol functional group, right? To the alkanol functional group. Now first we're going to look for which numbering system will give this functional group the lowest number. For the 4 numbering system, this substituent is going to be labeled 2. It's going to be placed on carbon 2, while for the backward is going to be placed on carbon 3. It's not obvious that we have to pick the 4 numbering system, unlike question 1 where both numbering system give us the same number in the carbon that was attached to the substituent. This one is giving us a different number, so remember I'll pick the one with the lowest total number, which is in this case is 2, right? So that's the OH group. Now the longest continuous carbon chain is 4, and 4 carbons, we refer to that as butane, right? As butane. Now 4 carbons is referred to as a butane if the compound is an alkane. But the fact that we have the OH functional group attached to it, this makes it the compound an alkanol, right? So this compound is referred to as an alkanol. The question is, what kind of alkanol? Since we have 4 carbon as the longest chain, it's referred to as butanol, right? But we can't just say that this is butanol. We have to specify which carbon the OH group is attached to, right? So this is an alkanol, 4 carbon chains make it butanol. So, and the carbon which the OH is attached to is carbon 2 for the 4 numbering system. So that obviously becomes butan. We attach it right after the N, right? Butan 2-ol. So this compound is named butan 2-ol, right? So this is the correct IUPAC mixture for this compound. Question 3.